In this video, we will try to solve a problem that was asked by a brother regarding how to find the Hicksian demand function, indirect utility function, and Marshallian demand function with a given expenditure function. Okay, it will be very useful video for you people. I will discuss all the stuff how to find these very things in a shortcut method. Okay, so we are being given the expenditure function like this. Is a function of price and utility, that is p1 raised power 1 upon 4 into p2 raised power 1 upon 4, where p1 and p2 are the prices and u is the utility. We have to derive the utility Hicksian demand function first, what we call the compensated demand function. Okay, after that, using the answer in part first and the expenditure function, we have to derive the Marshallian demand function, what we call the uncompensated demand function, and we have to also derive the indirect utility function. Okay, so leaving this question aside, let's discuss about the consumption duality. What is meant by consumption duality? Consumer is always facing two choices. Okay, so by two choices, what we mean, either he can maximize his utility with the given budget, or he can minimize his budget with the given utility. Okay, so what graphically this means and what it means algebraically, let me try to show you. So if we have a consumer, okay, let us say we have x1, x2 are the two goods here. Okay, this first function is like this. Either the budget is given to the consumer. Okay, so with the given set of budget, the consumer wants to achieve the highest possible utility. Okay, so like this is IC first, similarly this is IC second and IC third. Okay, let us see, this is IC third, IC second. Okay, so first choice is for the consumer. If the budget is given, he wants us to reach with the given budget to highest possible utility. Okay, that means highest possible indifference curve here. Okay, and where does he will achieve his optimality condition? That is when the indifference curve and budget lines are tangent to each other. That means he will consume at this point. Okay, let us write it x star, x1 star, and x2 star. Okay, this will be his optimal choice. That means this is first thing he can do. That means this is known as maximize utility, okay, of x1 x2 subject to the given budget. That means p into x should be equal to his income. Okay, and we call it primal problem. Okay, primal uh, problem. Okay, another situation can be, let me draw the graph here again. Another situation can be like this. The consumer is being given as certain utility. That means the utility is given to the consumer. Okay, the consumer wants to reach to this very indifference curve. Okay, he wants to reach this very utility such that to minimize his expenditure. Okay, to get this very utility, the consumer will try to minimize his expenditure in such a way that he reaches. Okay, let us say we have three expenditure curves here, budget curves. Okay, to reach to this utility, okay, what does the consumer will try to do? He will try to achieve the optimal bundles with minimum budget possible. Okay, that means we have to minimize the expenditure so as to reach to the given level of utility. That means optimal budget will be where these two, that is indifference curve and budget line, will be tangent to each other. Let's say this is x1, this is x2. Okay, we call this the minimization problem. That means we want to minimize our expenditure. Okay, minimize our expenditure. Expenditure is p into x, that means price into units brought. Okay, minimize this expenditure subject to the given level of utility. Let us say u of x is equal to, okay, to get this fixed level of utility, consumer will try to achieve this very level of utility with minimum possible expenditure. Okay, so we call this dual problem. Okay, dual problem. Okay, now let me rub this out. Okay, uh, So this is like this. Now what is our primal problem? Let me write it like this. So we have two problems here. What is called, one is called primal problem, another is called dual problem. Okay, primal problem, which I have told you earlier here, that we, in the primal problem, what is being given, we want to maximize, okay, we want to maximize our utility from the consumption of the goods given the budget constraint. Let us say budget constraint is px is equal to m. Okay, this is what we show here. Okay, so in this case the budget line is given and the consumer will try to reach the highest possible indifference curve. Okay, and in the dual problem we want to minimize our expenditure. Okay, such that utility level is given. Okay, with the given set of utility. Okay, with a fixed utility like this can be, we are being given the utility level, we want to achieve this utility level with the minimum possible expenditure. Okay, this is the dual problem, this is the primal problem. Okay, now when we solve this very problem, okay, when we solve this very problem, what we get the Marshallian demand function. Okay, Marshallian demand function. I have solved many problems on the constraint node optimization. It is very much simple. Okay, let me give you an example. Let us say we have to maximize, we are being given a utility function like this, u is equal to xy, okay, subject to px into x plus py into y is equal to y m. That means our income. Okay, we want to maximize this utility with the given budget. Okay, how do we solve this? We form the Lagrange's function like this. xy, I have shown you n number of times. I will also put the link of those videos in the description box to show you how do we do this. Plus we write lambda m minus px into x. This is subscript x. Okay, sorry for this. Plus py into y is equal to, okay, this is our Lagrange's. After, when we solve for the optimal values of x, y and lambda, we get the x value, okay, we get the y value. Okay, so similarly if we solve this primal function, we will get the Marshallian demand function, and it will be like this. Our Marshallian demand function will be like this. Let us denote this by x subscript m. That is Marshallian demand function will be like this, will be the function of price and income. Okay, so our Marshallian demand function is the function of price and income. Okay, similarly when we solve the expenditure minimization problem, we get Hicksian demand function. Okay, I am not able to remember the proper pronunciation here. Okay, so Hicksian, sorry, what is let me write it again. HIC, I am not able to remember whether it is, let me write it HIKSIAN. Okay, so Hicksian demand function. Okay, when we solve for the optimal values of x and for x's here. Okay, so I am just using x here to make them things here simpler. Okay, so what will we get here? We will get x subscript h will be equal to, x will be the function of price and utility. Okay, so the first difference between the Marshallian and Hicksian demand function is that Marshallian demand function is the function of price and income, Hicksian demand function is function of price and utility. Okay, sorry. Now after that, what we do, when we insert this value thing, this optimal value back again into our maximization problem, maximization function. This in this utility function we get indirect utility function. Okay, indirect utility function. When we put this value here, okay, we get this indirect utility function. And this indirect utility function can be written like this: u is a function of, let us say, price and income. It is also the function of price and income. Similarly, when we put this Hicksian demand, the optimal values of this Hicksian demand function in our this function, this minimization, or what we call the objective function, what we get in return, we get the expenditure function. Okay, we get expenditure function. And this expenditure function, let me write it like this: m is equal to, let us write this, c, expenditure function or cost function is the function of price and utility. Okay, I hope I am making myself clear. The endeavor of this video is to make all the steps available for you, okay, to get all the things in one frame. Okay, that's why I am taking the time here. Okay, now we are done with these things. Okay, now you can see we are being given the expenditure function. Okay, we are at the last step of our question. Okay, since we have to extract from this expenditure function, okay, we have to extract from this expenditure function the Hicksian demand function, the Marshallian demand function, and the indirect utility function. How can we do this? Okay, let us see. Okay, now if this is our expenditure function, okay, to get the Hicksian demand function from this, what we do to get the Hicksian demand function, let me write it like this: what we need to do, we need to differentiate this expenditure function, okay, with respect to price. Okay, I repeat here: to get this Hicksian demand function, how can we get the Hicksian demand function? That means, let me write it here, xh. To get the value of Hicksian demand function, we need to differentiate this in expenditure function with respect to p to get the this Hicksian demand function. Okay, also here, to get the Marshallian demand function, okay, to get the Marshallian demand function, what we need to do, we need to differentiate this, what we call this indirect utility function, okay, with respect to with respect to price, obviously, and divide it by the partial derivative of this indirect utility function with respect to income, okay, to get the Marshallian demand function. That means x superscript m, that means Marshallian demand function will be equal to minus dv upon dp divided by dv upon dm. Okay, I hope I am making myself clear here. Okay, so this very thing will give us the Marshallian demand function, and this will give us the Hicksian demand function, and this is called what we know, the Roy's identity. Okay, this is our Roy's identity, and this is called our hoteling lemma. Okay, hoteling or Shepherd's, sorry for my spelling, it can be very disastrous sometimes. Okay, or what we call the Shepherd's lemma. Okay, now what is Roy's identity? It is simply we use Roy's identity to get the Marshallian demand function from the indirect utility function using this very expression. Okay, similarly, what is hoteling lemma? It is simply used to get the Hicksian demand function from the expenditure function. Okay, also, now since this is our indirect utility function, this is our expenditure function. Okay, here utility is a function of sorry, utility is a function of m, that means income, and here income is a function of utility. Okay, so we can swap them, that means from this, if we use m is equal to e, that means if we write income as expenditure, or if we write v is equal to u, okay, we will get the indirect utility function from the expenditure function, or we can derive expenditure function from the utility function. Okay, so let me show it here also. So coming to the question first, then I will explain it in clear terms. Okay, so first we need to derive the Hicksian demand function. For that, what we need to do, since we are here, okay, we are here, so to get the Hicksian demand function, we need to differentiate this expenditure function with respect to price to get the Hicksian demand function. That is our question. Okay, so sorry. So how can we derive the Hicksian demand function? We need to differentiate this expenditure function with respect to price. That means, let me write it here, x h x1 h, that means Hicksian demand function for good x1 is equal to the derivative of this expenditure function with respect to p1. Okay, p1. Okay, so we need to differentiate this with respect to p1. Okay, so this 1 upon 4 will become coefficient, then we have p1, this exponent will be subtracted by 1, so this will become minus 3 upon 4, then we have p2, 1 upon 4, and obviously we have this u here. Okay, this gives us the Hicksian demand function. So let me write it here. If we transpose this here, this will become 1 divided by 4 p1 raised power 3 upon 4. Obviously, you know, if we change numerator to denominator, exponent sign gets changed. It is minus 3 upon 4, this becomes plus 3 upon 4. Obviously, then we have p2 1 upon 4 and utility. Okay, so this is our Hicksian demand function for good x. Similarly, Hicksian demand function for good x2, let me write x superscript 2, that means partially differentiating the expenditure function with respect to p2 this time will give us the Hicksian demand function for good x2. Okay, so this is 1 upon 4. Obviously, since we are partially differentiating with respect to this p1 will remain as it is, 1 upon 4, then we have p2, and this exponent is subtracted by 1, so this becomes minus 3 upon 4. Okay, I hope I am making myself clear here. And we have this u, which when we simplify, this will become 1 divided by 4. Transposing this term to the denominator, the exponent sign will get changed. This is p2 raised power 3 upon 4. Okay, then we have p1 raised power 1 upon 4 and u. Okay, these are our Hicksian demand functions. Okay, now the question tells us, using the answer in for first and the expenditure function, derive Marshallian demand function. Okay, so my thinking here is this part should have been at the third one, and third one should have been at the second one. Okay, so first we need to calculate the indirect utility function. How can we derive the indirect utility function from the expenditure function? Okay, it's very simple. If we solve this very function for u, we will get indirect utility function. Okay, I have just told you, since utility is a function of expenditure, expenditure is a function of utility function. If we solve in both ways, we will get either expenditure function or utility function. Okay, I repeat, to get the indirect utility function from the expenditure function, what we will do, we will solve this very expenditure function for u. Okay, so we are being given as e is equal to p1 raised power 1 upon 4 p2 raised power 1 upon 4 u. Okay, to get the indirect utility function from this, what will we do, we will solve this for u to get the indirect utility function. That means u is equal to, so u is equal to, if we transpose this thing it will become e. Okay, here e and m are same, that means income or expenditure. These two terms will get divided, this will become p1 raised power 1 upon 4, p2 raised power 1 upon 4. Okay, this is our indirect utility function which we, and obviously this indirect utility function is a function of price and income here. Okay, so it can be also written, if we write it like this, this v is function of income, so e, p1 and p2. Okay, and also Hicksian demand function is a function of price and utility. So we got the indirect utility function, we also got the what we call the Hicksian demand function. Now we need to calculate the Marshallian demand function. To calculate the Marshallian demand function we have two ways. Okay, what we can do here, if we insert this indirect utility function, okay, indirect utility function in Hicksian demand function, this will give us the Marshallian demand function. Okay, so you will get all the stuff here. That means if we put this indirect utility function, okay, in Hicksian demand function, we will get the Marshallian demand function. Okay, so let me write it here. So x superscript m denotes here the Marshallian demand function. Okay, so Marshallian demand function is derived when we put the indirect utility function in Hicksian demand function. Okay, so what is our Hicksian demand function? This is 1 divided by 4 p1 raised power 3 upon 4, then we have p2 raised power 1 upon 4, and in place of u we will write this very thing. Okay, so we have e, so I can also write here m. Okay, let me write here m because e and m are synonymous here. So p1 raised power 1 upon 4, then we have p2 raised power 1 upon 4 obviously. Okay, so let's do some cancellation here. What can we cancel? अगर go के cancel जान go नहीं तो तेरे सवाल को मुझे गलत. Yes, we can. ठीक है. So we are left with, here we can see we have p1 raised power 3 upon 4, p1 raised power 1 upon 4. So it is like this: p1 raised power 3 upon 4 into p1 raised power 3 upon, sorry, 1 upon 4, 1 upon 4. Since bases are same, powers can be added. Okay, so we can write p1 raised power 3 upon 4 plus 1 upon 4. It becomes p1 3 upon 4 plus 1 upon 4. Since denominators are same, we can add up the numerators. So this becomes 4 divided by 4. This becomes p1. Okay, so let me wrap this out. Actually I have the plenty of space here. So this can, if we manipulate this, it will come out to be, obviously it is for good one, it will come out to be, we have m here. Okay, then we have this 4. When multiplying p1 and p1 here, we get only p1. Okay, this is Marshallian demand function for good one. Similarly, Marshallian demand function for good 2 bego galat is equal to, okay, we again need to put this indirect utility function in this equation to get the Marshallian demand function for good 2. That means so let us write it here. So we have 1 upon 4, then we have p2, then raised power 3 upon 4, then we have p1 raised power 1 upon 4, and to this in place of u we write this iuf. What is in place of e? I am writing m here. Okay, so no need to worry here. So we have 1 upon 4 p2 1 upon 4. Okay, let us see if there is some cancellation possible. So yet you go robust sawal, it go robust mighty. We are left with again p2 raised power 3 upon 4, p2 raised power 1 upon 4. Bases are same, exponents are added, so we are left with m divided by 4p2. Okay, clear. So we got all the stuff in one place. This same result could have, rather, this same result can be achieved if we use Roy's identity. Okay, tt Roy's identity. Okay, sorry for my broken what we call my disastrous English, but I'm not feeling anything nervous in this video, because if I am able to impart my knowledge to you people, okay, I don't care about my English at all. Okay, so the first priority is just to impart the knowledge. If it comes with a broken English, it's okay. Okay, so I appreciate for your time. Okay, so this video is getting lengthy, so don't worry, but you will get all the stuff here. Now there are two methods of calculating the Marshallian demand function. Okay, I have told you first method is just plug the value of indirect utility function into the Hicksian demand function to get the Marshallian demand function, what we have done here. Okay, so if I can beautify this, so let's try to क्या करो यार जाय कपड़े काढो should I rub? I should have rubbed this, but there is no space available, so let me think. What can I do here? So let me rub this here first. Okay, let me write this is equal to, because I have calculated it, so x is equal to m upon 4p2. This is our Marshallian demand function for good x2. Similarly x1 is also here, we have calculated it, so let me rub this out also. Let me write it here. So we got here m upon 4p1. Okay, so since we have to differentiate between Marshall and Hicksian demand function, so I am just writing them here. Okay, now I will use the Roy's identity in calculating the Marshallian demand function from the indirect utility function. Okay, so this is our indirect utility function which we calculated from this expenditure function. Okay, so we calculated this from this expenditure function, so this gave us indirect utility function. Now to get the result here, what we need to do, let me write here x subscript then superscript, okay, x1 m. To get this same result using Roy's identity, we use this very function. That means we write minus d, I'm using u here. Okay, let me write here du, okay, with respect to p1, okay, divided by du upon dm. Okay, now what is du upon dp1? That means I should be current differentiate yes like time. So so let me show you how to find the derivative of this very function with respect to p1. Okay, then I will rub this out. Okay, I'm not having the space left here. Okay, so how can we differentiate this very function? This function can be written like this. I can write this very function like this. Let me write it here. If I write it like this, so we can write it like this: e p1 raised power minus 1 upon 2. Okay, I'm just transposing this to numerator. The exponent sign will get changed. Okay, so the sign of the exponents obviously. Then we have p2 raised power 1 upon 4. Okay, we need to differentiate this with respect to p1. Okay, so we have our choice variable here. Using power function rule, this minus 1 upon 4 will become the coefficient, so this becomes 1 minus 1 upon 4. Then we have e p1, okay, minus 1 upon 4 minus 1, this becomes minus 5 upon 4 divided by p2 raised power 1 upon 4, okay. And when we solve, this will come out to be minus 1 upon 4, okay. I'm just trying to solve this very thing here first, okay. Then we have, if we transpose this back here, so we will get e divided by p1, so p1 5 upon 4 tha choice here. Then we have obviously p2 1 upon 4, okay. I'm just using some manipulation here. Now what can we do here? This is our numerator part, okay. So let me write it like this, minus e, actually I'm not getting the space here, so that is why I am going here, p1 raised power 5 upon 4, p2 1 upon 4, okay. This is our numerator part here. Now let me have a sip of tea, okay. We have calculated this numerator part here. I'm just trying to show you how do we use rise identity here. Now what is the derivative of this very thing? Du upon dm, sorry, du upon dm, that means partial derivative of this indirect utility function with respect to income. So let us write it here, m, okay, in place of e. E and m are here synonymous, I am telling you. Now this thing is our numerator, okay. What is the derivative of this very function with respect to m? So the derivative of m is 1, so we are left with this thing again, okay. So sorry, so in place of this I can write like this, minus this very thing we have again minus e divided by 4p1 raised power 5 upon 4 p1 upon 4, okay. This is our, let me write it properly, this is the derivative of this very thing, okay, divided by the derivative of this very function with respect to m will be this thing, that is the derivative of m is 1, so I will write here 1 upon the whole step here, that is p1 raised power 1 upon 4 p2 raised power 1 upon 4, okay. So let me rub this out to solve it further. So we are solving it for x1. I will not be able to solve it for x2, it will get very lengthy then, okay. So this minus and minus will get cancelled, we are left with, so I'm just using e again, so let us write this as m, okay. So we have m divided by 4 p1 raised power 5 upon 4 into p1 raised power 1 upon 4. If we transpose this, it will get reciprocated, okay. So numerator becomes, denominator will become numerator here, so we have p1 raised power 1 upon 4 and this is p2, okay, p2 raised power 1 upon 4 divided by 1, okay. This be yet go cancel, okay. So we are left with, if we transpose this p1 to the denominator, the exponent sign will become negative, so we will be left with m divided by 4 p1 raised power 5 upon 4 into p1 raised power minus 1 upon 2, okay. When the bases are same, we can subtract the exponents or add the exponents here, okay. So p1 into p1, exponents are same, we can write it like this. Let me write it Hi. Let me write it like this here. So we will be left with m divided by 4p1. Okay, you can clearly see this thing, why this p1 becomes why there is no exponent here other than 1, because 5 upon 4 minus 1 upon, actually it is 1 upon 4 here. Okay, 1 upon 4, when we subtract it, this comes out to be 4 upon 4, it comes 1. Okay, so I'm not doing anything wrong here. So here you can see, if we use Roy's identity, we get the same Marshallian demand function for good x1, and similarly if we write du upon dp2, okay, we will get the Marshallian demand function for good x2. Okay, I hope I make myself clear in this video. Let me repeat it. How did I calculate this? Actually, it was a complicated question, because usually we are being given the maximization problem or minimization problem with their constants, obviously. Okay, but the question is not straightforward here. We are being given the expenditure function, we are at this point, and from that we have to calculate the Hicksian demand function, Marshallian demand function, and indirect utility function. Okay, so how do we solve this very function? I have given you a broad picture. How can we do this? If we have the primal problem, that means we want to maximize utility with a given budget. If we have dual problem, we want to minimize our expenditure with the given to get the constant utility. Okay, so when we solve this very thing, we get Marshallian demand function, which is the function of price and income. And when we put this optimal value again in objective function, we get indirect utility function. Same is here. Okay, when we solve this, we get here Hicksian demand function, which is function of price and utility. This is the function of price and income only. Okay, so to get the expenditure function, what we do, we just put this Hicksian demand function back in this objective function to get the expenditure function. Okay, now how do we get indirect utility function from the expenditure function? Solve this very function for you to get the indirect utility function. Okay, after we get the utility for indirect utility function, just plug this indirect utility function value in the Hicksian demand function to get the Marshallian demand function. Okay, how do we get the Hicksian demand function from expenditure function? We use the hoteling lemma or Shepherd's lemma. That is simply, we differentiate the expenditure function with respect to price to get the Hicksian demand. Okay, similarly, if we want to find the Marshallian demand function, there are two ways, either to go highway or to my way. Okay, sorry. So either to put the utility for indirect utility function into the Hicksian demand function to get the Marshallian demand function, or there is another straight way, just to use the Roy's identity. That is, the Roy's identity is the ratio of the partial derivatives of this indirect utility function with respect to price and income to get the Marshallian demand function. Okay, I hope I make myself clear in this video. If you like these videos, please share and subscribe your friends. This is the only motivation for me to keep going on. I am making this stuff for free. No, you don't need to give a single penny to me. Just I am doing you as a welfare process. Okay, there is no what I can say, there is no other constraint for me here. Okay, so I hope I make myself clear in this video, and I hope you find this video useful for you people. Okay, or obviously what I can say, I have nothing to say. Thank you.